So the pocket transit is the geological compass that we use to take three-dimensional orientations of physical features such as formations of rocks and so forth. But there are many other geological compasses out there. We just happen to use the Brunton. Be very precise with it, and in general it's hard to break them. But as you can see, even your iPhone, your smartphone will have an app that you can download, and that will be able to take strikes and dips and get your bearings and so forth. So right now we're going to go over parts of the Brunton. First off, there's the case. Now when you put your Brunton in the case, it's important to always put the mirror side, which is the thin side, along the belt loop of the case. That way it protects the mirror when you're going around jumping off rocks. If you happen to land on the mirror side when it's out, you might shatter it. So, step one, open it up and take it out of the case. Now, start to zoom in here a little bit, and you'll see that there's this ambiguous black portion right here, and then there's this other portion right here. It's kind of hard to tell which is the hinge. So the first thing you do is you locate the black part, and then that's where you open. So you should put your thumb in there and pop that out. Now there's a few other pieces that we'll talk about. Here's the mirror. The mirror has many uses. You can use it to shave if you need to, as well as sighting things and signaling, which we'll go over later. Within the mirror, there is a line going across it. That goes along the axis of the compass. So if you're going to sight with it, you know that that is perfectly centered. Also within the mirror there is a hole. We call that the sighting window, and then you also use that to sight. And conveniently, through the sighting window, the axial line continues. So when you're looking through that, you know where exact center is. Then there's these things protruding from the side of the compass. There's the folding sight right here, which is a small one, and then there's the sighting arm. The sighting arm has a little peep sight at the end right here. Now both of these sights have a little widow's peak on the center of it, and that helps just define the axial line as well. Now once you figured out where the sights are, you want to go inside the general window of the compass right here, and within the bulk of the compass there are numbers going all the way around it. There's two types of compasses, there's azimuthal and quadrant compasses, and we'll go over those on the next slide. But keep in mind that for both compasses, numbers on the outside represent a bearing relative to north. Now, there's two levels that you'll notice are inside the compass. One of them is cylindrical and the other one is circular. If you are using the clinometer, which we'll go over shortly, you're going to use the cylindrical one. The other is the round one, and you use that for strikes and dips, which we'll go over shortly, and that tells you when the compass is horizontal. Let's see. Other things to consider are where's north? Which part of the needle points to north? And always just remember the white part is pointing to magnetic south, which we consider our north pole magnetically. Another part right here, there's the lift pin. Now if you were to close the compass, you'll notice that the lid pushes down the lift pin, and what that does is locks the compass so that when you shake it and walk around, the needle doesn't shake around like that. Later on, when you get better at strike and dips, you'll be able to measure something above your head and then push the lift pin and freeze the needle in place, and that becomes convenient later on. See, the last, most important part that we need to talk about is right here. There's this little screw located on the hinge side, and what you can do with that is you shove your thumbnail or a penny or a key or something in there, and as you rotate that, it rotates the bezel within the compass face that has your bearing degrees on there. So when you're setting your magnetic declination, this is the screw that you'll use. Alright, so by this time you've all been passed out a compass and you're figuring out the parts of it, but you're wondering, do I have an azimuthal or a quadrant compass? Now, with a quadrant compass, you'll notice that the bearings go from 0 all the way around to 360. However, with a quadrant compass, you have 4 sections that go from 0 to 90. So, for example, a bearing of north 20 west, that would put you right there. North 20 west would be the same bearing as 340. So if you're talking to somebody or your field partner and you have different compasses, it can be slightly inconvenient, but eventually you'll get quick at making back of the envelope calculations to convert between the two. It really just comes down to preference. I like to use a quadrant compass because it's more old school. If I'm trying to tell someone where I am, I usually say I'm north 20 east of you. I don't say I'm 20 east of you or 340 or something like that. But it's a personal preference thing. The azimuthal compass is generally more internationally used. Alright, so setting declination. An important thing to keep in mind is that magnetic declination changes throughout time as a magnetic pole wanders around. In general, it hangs out around Hudson Bay, but it's never exactly in the same point for a long period of time. So always be up to date on your magnetic declination, where you're going. If you're unsure about what the declination is in your area, you can always just set your compass to 0 declination, and when you get back from the field you can convert everything. However, that is a hassle. So try and figure out what the modern declination is, and you can find that just by doing a quick Google search or going to usgs.gov. So in our area in Seattle or Washington in general, in 1995, when this image was created, it was about 20 degrees, 21 degrees. Right now, our magnetic declination is about 17. So this figure is out of date. So you want to know what, how do I declinate this compass right here? So we are about 17 degrees northeast for our magnetic declination. So that means the magnetic field lines are putting our compass about 17 degrees more east than they need to be. So to correct for that, you need to make your compass move 17 degrees to the west. So if we zoom into the compass more, you see I put my thumb in the screw, and as I rotate the screw, it turns the bezel on the outside. So what I do is I just rotate it around until it's at 17, like that. And what that did is it pushed 17 degrees on the west side of the compass. Now, at this point, you're probably realizing that north, south, east, and west. Oh wait, the east and west are flipped. What's up with that? So, the reason they are flipped around is because the Brunton compass is directional. It gives you a bearing of an object relative to where you are. So, to practice this, keep in mind where north, south, east, and west are supposed to be, and point at something in the room. So say I'm going to point at whatever is to the left of me, and as I move my compass to the east, from my perspective, what the compass does is, even though they're flipped, it still points to the east. So give that a try, get your compass out, point at something, and move it. Move the compass in the east or west, and you'll see that the white arrow does go to the correct quadrant of your compass. You just have to, if it's not obvious, just have faith in the Brunton that it is giving you correct information. But so yeah, if you want to know where something is to you, then you need to start taking bearings. So to sight with the compass, there are several things you can do. There's a few different, basically, strategies for sighting with the compass. So keep in mind we'll be using the north arrow, which is the white arrow. Now there are two techniques you can do. Both techniques use the axial lines through the compass, meaning the line on the mirror, the line through the peep window, the peep sight, and the fold sight. Now to take a bearing like this down here, this is a very comfortable way to take a bearing. What you would do is you pull your long sight up at about 45 degrees relative to the bottom of the compass. And then you bring your window up at an angle that's equivalent to the long sight. And then you have an image of your long sight in your mirror. Now what you need to do next is look at the circular level and put the air bubble in the center of the level. That means your compass is perfectly horizontal and your needle is properly balanced. And also, whatever you look at, that is along the hinge line, or the axial line, is now at the bearing your compass tells you. So this is telling me that the camera is north 10 east of me. So I'm reading this directly off the compass bezel, and everything is lined up. Now, an important thing to keep in mind, if you are pointing at something using the long sight, that you want to take a bearing using the white arrow. However, if I were to flip the compass around, like this, which is the next method we'll talk about for sighting, what I'm looking at, to get a bearing from me to that object, I have to now read the black line, the black needle. So the second technique that we're talking about, the compass is now reversed, so I'll be using the black line. I use this for sighting something at a great distance that I want to be very accurate. However, this is a lot more complex. So to do this, I'm going to utilize the peep window, and then the hole in the mirror right here, and the bubble again, but this time I'm going to read the bubble backwards using the mirror. So what I do this way is I look at an object, a mountain peak off in the distance, through the hole, through the peephole and the hole in the mirror. And while I'm doing that, I am also looking at the mirror to see the bubble. So now I can see the circular bubble at the bottom of the compass, and now it's level. So I know whatever I'm looking at is on an exact horizontal plane away from me, meaning it's at the same elevation for the most part, and I can take an exact bearing. Now if it's kind of hard to read it, this is when that little white button we talked about, I just locked it, pushing that button right there. So what I can do now is read off what the compass says, and I know it's exactly what it said when it was this way because I locked the needle. And then, yeah. That's the second technique. So when you're utilizing triangulation, I like to use this method the most. However, if it's something closer up, I'll use this method. But keep in mind, if you're using this method, long sight out, you're going to read the white arrow. If you flip the compass around, you want to read the black arrow. All right, next we're going to talk about the clinometer. Now, every Brunton compass has a clinometer in it. And what that does is it utilizes the cylindrical level. Now, that level is controlled by this little swing arm in the back of the compass. This guy rotates 180 degrees from side to side, like so. And when I do that, it's rotating the clinometer on the inside of the compass, like so. Now, the clinometer is set relative to the bezeled edges on the side. The sides of the compass are parallel and perfectly flat. Now, if I want to find out what angle something is at, what I do is I hold the compass up to it, like so, and then I adjust the clinometer until the bubble resides in the center. And what that does is it gives you the angle between horizontal, the bubble, and the angle of the compass. So right now, this tells me that I am holding the compass at exactly 40 degrees. There are two readings along the clinometer, so make sure to look at your clinometer at this point. Depending on the model of the compass, it will change where exactly this information is located, but in general, there will always be numbers ranging from 0 to 90 in both directions, and that gives you degrees. But then also there's a percentage, and what that's giving you is a percent of grade. Like if you're driving along the road and you see a sign that says danger 12% grade, that's what it's the same thing. We never really use that for taking strikes and dips or trends and plunges, so in general you can not worry about it. Alright, now we're resuming with an example of how to take a strike and dip using a Brunton compass. So what we have here is a masonite board that is angled with respect to the table at about, about 40 degrees, 30 degrees. And we're going to walk through the steps now to how to take a strike and dip using the Brunton compass. So a Brunton compass will tell you the orientation of a planar surface. So in our case we have a masonite board, but in other cases you'll have bedding of a rock unit, foliations in general of minerals, planar alignment of minerals, the limb of a fold, and also the fault surface. These are all examples of something that you can take a strike and dip of. So step one to take a strike and dip is you get the flat edge of the compass and you put it flush. By flush I mean you can't push it down and wiggle it anymore. It's flat against the surface. Not the whole thing. I don't want to make the whole flat side touching, just the bottom edge. Now once I have the bottom edge with full contact to the board, I rotate it around the angle until the circular bubble within the compass is level. So right now the air bubble is in the center of the compass and I get a reading. Now there's a reason that I have the compass pointing in this direction, and that is what we call the right-hand rule. Whenever you have a planar surface and you want to know which way to put the compass, the right-hand rule is you put your thumb down in the downhill direction, and whichever direction your pointer finger is pointing, you have the long sight in that direction. So now that I have the right-hand rule, I know that it's going to be pointing this way. I have my center bubble leveled, I get a pencil out, and then you use a flat surface on the compass, and that draws a line that is parallel to the horizontal surface that we're portraying right now. So in our case, this etching that I did is an example of the line formed by a horizontal plane intersecting this plane in question. So that gives me a bearing of north 85 east. Now what I need to do is take the dip. And keep in mind the dip is always perpendicular to the strike. However, the dip is along a vertical plane. So what I need to do now is orient my compass perpendicular to the line I just formed on the board. And then I get down real close to the compass, and I'm looking inside at the clinometer. And what I do now is I rotate the clinometer until this bubble right here is centered. So right now that bubble is centered, it's perpendicular to my line of strike, and I get a degree of 32. So now I would say that this masonite board is oriented north 85 east, 32 degrees to the north. Now what I'm going to do next is show you how to take a trend and plunge. Now a trend and plunge is for a linear feature, whereas the strike and dip is for a planar feature. So So we've taken a dimension out. The rules for trend and plunge is just point the long sight in the downhill direction. So in our case here, we have a line across the masonite board. The first thing you do is put your feet across the linear feature and look down through the long peephole in the long sight. And while you're doing that, you also want to make sure the horizontal level is centered. So when I have the horizontal level centered, a line is directly in the peephole, the long hole. That tells me that this line is oriented north 20 degrees west. Now the next step, now that we've established the trend of this linear feature as north 20 west, we need to describe how it's dipping into the Earth's surface with respect to horizontal. So to do that, we're back with the clinometer. And to take the plunge, what you want to do is line up the bottom line of this compass, that flat edge, with the linear feature in question. And keep your compass as vertical as you can. The compass is close to vertical. I use the clinometer and I adjust it until the cylindrical level has the air bubble in the center. And that tells me that it is dipping 15 degrees with respect to horizontal as it plunges into Earth in the north 20 west direction. Alright, now that we've gone over how to take a strike and dip and a trend and plunge with the Brunton Compass, what we're going to go over now are two more advanced techniques. The first one being triangulation. Now, triangulation comes in handy when you're hiking around or producing a geological field map and you don't know exactly where you are, but say there's a few prominent topographic features on the map that you can locate. If you have a compass and those features on the map, then what you can do is triangulate yourself. Now triangulation, tri comes important here, meaning 3 points. 3 is the minimum amount of bearings you want to take to locate yourself moderately accurately. Now, keep in mind the techniques that we talked about previously for taking a bearing. There's two ways. There's the method where the long sight is away from you and you look down into the mirror and whatever you're looking at is whatever bearing the white arrow says. So in this case, what I'm looking at is north 10 west of me. So if I want to find out where I am from that object to myself, say if I want to walk from the object over there, I'm going to walk south 10 west, the exact opposite of what the bearing says that object is from me. Now, there's the other technique that we talked about. When you rake out the long sight, flip up the peephole and look through the window with the mirror down. Keep in mind with this technique, you follow the black arrow and that tells you the bearing that object is from me. If I want to find out how to get from that object to me, I follow the opposite bearing. So the black arrow tells me where that thing is. The white arrow would say how to get from there to me. So you're in the field, you're mapping, but you don't know where you are. On the PowerPoint here, there are 3 prominent features that the mapper has located. There's this little spot along the drainage, a peak off in the distance, and another peak off in the distance. Now what you would do in this case is you get your Brunton out and you take a bearing. So we'll start with the one on the right. So say the mapper sees that object in the drainage, gets a bearing, finds out that it is north 10 east. What they would then do is get a protractor out and draw a perfect straight line that is south 10 west of that object. And then you know that you exist somewhere along this line, but you don't know exactly where. So you get a few more points. Now, up in the left corner, there's another peak at above 5,400 elevation over here. Now, say the mapper takes a bearing, and that tells them that to get to that mountain, they have to travel in the direction of north 45 west. So to get from that mountain to you got to go south 45 east. So we'll draw a line along that bearing, south 45 east. And then that tells you you're likely along where these two lines intersect, but to be sure, what you want to do is have a third point. So the mapper who's lost picks this mountain on the bottom left over here. And that tells them that that mountain is about north 70 west of them, so they must reside about south 70 east, the exact opposite of the bearing. So if you draw a line in that way, it'll give you a little triangle. In this case, this triangle is pretty small down here. In most cases, it'll be a lot larger. And that comes down to accuracy and precision problems, mostly that of the user. The Brunton will give you an accuracy within a half degree. So if you get your bearings, give you a triangle that is large, it's either you weren't pointing at the location exactly, or it's a really wide object and you can't be too precise. But this triangle varies in size and you are located somewhere within it. Alright, next we're going to talk about using the Brunton Compass as a signal mirror. This is not only fun, but it also comes in handy both for survival and mapping techniques in general. To signal with the Brunton Compass, there's two things you need to take into account: where the sun is and where the object you are trying to signal is. Now, the first thing you want to do, say in my case the sun is up here. What I want to do is make it so I cannot see the sun. My Brunton Compass mirror is between myself, my eyes, and the sun. And a way to check that is you can hold your palm out and there'll be a little spotlight that is created by the sun traveling through the hole in the mirror. And that lets you know that the sun is between or on the other side of the compass. Another way to tell is you're not getting the glare in your face from the sun. And the second thing you want to do is look at the object that you would like to signal using that hole. So I keep that angle the same, and I'm looking at the camera, in this case, through the peephole in the window. If you find that using the hole is a little complicated, just cover up the sun and use the edge of the mirror, and that's just as effective. And then if I have a light source over here, it's going to reflect at the exact angle required to send a beam of light in the direction I would like. The next thing you want to do is just vibrate the Brunton, and that'll create flashes of light. If you happen to know Morse code, then you can do that as well, send a little SOS. But you'll find that this comes in handy pretty often for finding your field partners, as well as getting the attention of cars and airplanes if you're lost. So yeah, that concludes the introduction to how to use a Brunton compass, and happy mapping.